Today we will see how to implement selection sort. Selection sort is the easiest of sorting algorithms. If you understand how to do a selection sort, you need not see the code, you can implement it yourself. It's that easy. Even if you are a beginner who has just begun your programming journey. Let's take an example to understand what a selection sort is. 25, 3, 90, 32 and 5. Selection sort just means selecting the smallest element from the array and placing it in the right position. Now we find the smallest element in this array. The smallest element is 3. So we will swap 3 with the 0th index. 3, 25, 90, 32, 5. So we have 3. If you see it clearly, 3 is already in its final position. Since it is the smallest element in the array, it should be the first element. Now in the second pass, your aim is to find the smallest element in the remaining part of the array, so it can be filled in this index 1. So the smallest element in this array is 5. So we have to swap 5 with position 1. After second pass, we have 3, 5, 25, 90 and 32. Now the first two elements are already in its final position. Now our aim is to find the smallest element in the remaining part of the array to fill this position. The smallest element is already 25, which is in its right position. So we need not swap anything. At the end of third pass, we have 3, 5, 25, 90 and 32. We have 3 elements already sorted and in its right position. Now we find the smallest element in this array. It is 32, so we swap it with 90. We have 3, 5, 25, 32 and 90. So we have all the elements in this array sorted. So this is selection sort. Even if you are new to programming, grab a pen and paper and start implementing this algorithm in your favorite language. It's very easy. You will be able to crack it. If you are stuck somewhere, try hard to get it yourself. If you are unable to, or you have completed and want to verify whether you did it correctly, start watching the remaining part of the video. Let's implement the simplest of algorithms, that is the selection sort. We pass the array and we pass the number of elements in that array. In some languages, you don't need to pass the number of elements of the array because you can get it right from the array itself. Now, let's start implementing the algorithm. For int I equal to 0, we start from the first position and go till the last position, I less than n, I plus plus. We want to find the smallest element in the remaining part of the array and swap it with the current position. So we will consider the current position as the position with the smallest element initially. Int sum position, smallest position equal to sum position I. The way to find the smallest element is compare the current element with the smallest element, and if it is smaller than the smallest element, then the current element is the new small element. for j equal to I plus 1, j less than n, j plus plus. We go till the end to see which is the smallest element. And every time we will check if current element ARR of j is less than ARR of smallest position. If ARR of j is less than the smallest element, then ARR of j is the new smallest element. So SMPOS is j. We do that for all elements in the remaining part of the array, and we swap it with the element there that we have in I. Swap ARR I and smallest position. With this, we swap the element in I with the element in the smallest position. So now after this one iteration of the loop, the index I will have the smallest element in the array. Swap is just a simple function. Void swap, pass the array and the two positions, int p and int q. Int k equal to ARR of p, ARR of p equal to ARR of q, ARR of q equal to k. We have two elements p and q. If we want to swap the elements 5 and 10 here, we take a new element k where we copy whatever is in p. So we copied it here 5. Then since 5 is copied, you can just replace the element in p with q. So we copy 10 here, so that is this, and finally we can copy whatever is in k to q. So we copy 5 here. Hope you were able to do the selection sort yourself. If not, you would have looked at the solution, the simple solution that selection sort provides. This is not an algorithm that I would recommend you use for your sorting purpose in real world programming, because for every element we are checking every other element in the array. That means we have n iterations here, and for every iteration we have n iterations here. So its time complexity is O of n square. Hope you were able to understand selection sort well. I will meet you with another algorithm next time. Thank you. Instead of telling you how an algorithm works, this guide tells you when to use it. Do you find yourself wondering which data structure or algorithm to use in a particular situation? Then this guide is definitely for you. Grab the guide by clicking the link in the description. Until we meet the next time, this is Shivakumar aka Algo Shiva signing off.